Hi everyone, welcome to Dr. RCM Academy. In this session, we are going to explain Biot-Savart Law. So, as all of us know, whenever there is a current flowing conductor like this, there is a magnetic field around that and it obeys the right hand thumb rule. So, if this is the flow of the current in the conductor, then these fingers will indicate the direction of flow of current. So, same thing is represented here. So, if the current is flowing in the conductor, magnetic field will be around the conductor in this direction. And Biot-Savart's law is there to explain what is the amount of field, magnetic field at any point in this field due to this current carrying conductor. So, let us explain that. Before that, suppose if you are not subscribed to the channel, kindly subscribe and also press the bell icon for further videos, and you can also like, share and comment and keep supporting, so we will be loading more number of videos relevant to electromagnetics. So, with this let us start Biot-Savart's law. So, let us consider first a current carrying conductor as shown in figure. Now, the figure is drawn as current carrying conductor. Let I be the current flowing through this conductor, and I want to find out what is the magnetic field at a point P due to this current carrying conductor. So, this magnetic field at this point due to this entire conductor, if I want to calculate, since it is a very long line. So, instead of which what I do, I take a differential length, a small current element. So, with a differential length dl and current flowing through this is I, therefore, this current element I call it as IDL, and let r be the distance from the current element to the point at which you are finding the magnetic field, and let theta be the angle between the current element to point where you are finding the field. So, with these assumptions, so let us state Biot-Savart's law. So, what does this Biot-Savart's law tells you? As I told, it is to find the magnetic field at any point P due to this current carrying element. So, Biot-Savart's law states that it is directly proportional to product of the current and the differential length, that is I into dl. So, it is directly proportional to IDL, and it also states it is proportional to sine of the angle between them. So, if theta is the angle between the current element and point P, then sine of it is directly proportional to sine of this angle, and it is inversely proportional to square of the distance between the point where you are finding the field and the current element. So, if I summarize all these statements together mathematically, that is, the magnetic field at point P, I represent it as dH, vector dH, which is proportional to, so it is product of I into dl and it is also sine of the angle. So, directly proportional to these two, and the last statement says that it is inversely proportional to square of the distance, that is r square. So, this is a magnetic field at point P due to this differential current element. So, to remove this proportionality, I will introduce proportionality constant. So, I represent dH equals to, in place of this proportionality I introduce a constant k. So, what is k is the proportionality constant, which is equals to 1 by 4 pi. So, if I substitute the value of k in this equation 2, so dH becomes, so it is IDL sin theta divided by 4 pi r square. In place of k, I have written it as 1 by 4 pi. Since magnetic field is a vector, but this is a scalar quantity, I have not completed this expression. Therefore, let us represent this in the vector form, for which we know the definition of cross product. So, cross product between let me say vector dl and unit vector ar can be written as magnitude of dl into magnitude of ar into sine of the angle between them. So, we know that magnitude of any unit vector is 1, therefore, you will get it as dl sin theta. So, if you look into equation number 3, dl sin theta, in place of dl sin theta, I can write it as vector dl cross product with unit vector ar. Therefore, so I represent equation 3 as, in place of dl sin theta, I represent it as vector dl cross vector ar, and we know that cross product of two vectors is a vector. Therefore, so left hand side is also vector. So, right hand side also is yielding the vector. So, which means that now the equation is satisfied, that means it is a vector, magnetic field is a vector. So, this is the magnetic field due to differential current element, and what is AR? As I said, it is a unit vector. So, we know that unit vector is vector r divided by magnitude of r. So, where magnitude of r just can be written as r. Therefore, in place of AR in equation number 5, I will write it as vector r divided by magnitude of r, that is nothing but r. So, equation 5 can be rewritten as, so dH can be written as I into dl cross product with, in place of vector AR, I will write, sorry, vector AR, I will write it as vector r by magnitude of r, vector r by magnitude of r. So, here you have r square, but r square into r is r cube. So, this is the magnetic field intensity at a point P due to differential current element what I have considered, but I want the total magnetic field at point P due to the entire conductor. So, this is just one element and this is the magnetic field due to that element. So, you may have such infinite number of elements or many number of elements. So, since it is a continuous, I will take, to find the total, I take an integral, closed loop line integral of I. So, this is nothing but dH, that what I already found for one differential current element. I integrate throughout the elements, throughout the line. So, I get what is the total magnetic field, that is line integral, closed loop line integral of I dl cross vector r divided by 4 pi r cube. So, this is the magnetic field at a point P, and using Biot-Savart law we came to conclusion that the magnetic field depends on the current. So, it is a vector dl cross vector r divided by 4 pi r cube. Thank you.